I've got the spinning wheel. Looks like success. Although, yes, I see Andy is nodding his head. So thanks, Andy. um, my name is Stephen Mangeron. I work for Homesol Building Solutions. We are energy conservation consultants, and just like EnviroCenter, we have energy advisors who provide the home evaluations required for all of these programs under the EnerGuide label. Um, so I've been working with HomeSol for about 13 years. I'm their senior energy advisor, a net zero energy advisor, net zero builder trainer. We're proud members of CASE, which is the Canadian Association of Consulting Energy Advisors, providing EnerGuide labels for existing homes for these programs, as well as new construction. We also work with builders in the area to achieve Energy Star for new homes, R2000, net zero, and net zero renovations as well. We've also been fortunate enough to work on some passive house projects. And I should say that if during this presentation, I'd be happy if people interrupt and raise some questions or ask for clarification as we go through, or you can just let me ramble on and complete the presentation, and then we'll open up the questions. Either way works for me. Sadie may have, these next two slides are actually from Sadie. Sadie was kind enough to provide this as part of sort of a package for these concierge presentations. They do have some nice links, but I do have a little bit of an update. So I'll just show you these two first, and then I'll just provide a quick update. These links are to all the eligible items, which is really important because when we talk about a product's eligibility, they need to be on these lists for NRCan to prove that these products are eligible. So that's really important, whether it's heat pumps or windows and sliding windows and all that. If you can find the product that is being installed in your home or being quoted on this list, then you can go ahead with confidence that they'll be awarded the grant or loan. One of our services that we provide, and I always stress this to my energy advisors, is that if they know that a homeowner is looking for these specific upgrades, that the homeowner send us the quote so that we can confirm for them, if they wish, their eligibility, or at least confirm that the information provided by the contractor has the appropriate information so that you can go forward with the installation, knowing that it's all correct and will be good at the end. We have received a recent update to the Canada Greener Homes Grant Program last week during a meeting with NRCan. And they're projecting that by the end of March 2024, so this coming March, they're going to stop accepting new applications to the grant program. The reason for this is that they see the trajectory of how many applicants there have been this year, how many applicants there are in scheduled already, and they've calculated that with that trajectory, the budget of $2.5 billion will be pretty close to being accounted for based on all the files, all the pre-retrofit files that will be in the system at that point, assuming that a certain percentage of them will be awarded the $5,000 grant. So please keep that in mind for those of you who haven't done your pre-retrofit evaluation. It would be good to do that sooner rather than later so that you're in the queue. As soon as you have that pre-retrofit evaluation and you're in the system, you're good to go. They haven't provided a deadline for the post-retrofit evaluation to be completed. So we're hoping to get that information soon, but I would imagine that it's relatively open. After all, this program was supposed to be a 5 to 7 year program, and I think they will have exhausted their budget within 3 to 5 years, 3 to 4 years, sorry. So that really speaks to the success of the program and how much people want to make their homes more energy efficient, which is fantastic. But yeah, that's a quick update for that. The $40,000 interest-free loan is not affected by this. It's administered by CMHC. All the eligible upgrades for the grant program are the same for the loan program. It is interesting that there is a $5,000 limit, but I don't know the specifics of that with respect to, well, if your heat pump system costs less than $5,000, well, that's interesting to begin with, but it would probably need to be a little bit more than that to qualify for the grant, for the loan. Apologies. So, yeah, that's just a quick update before I get stuck into it. I guess I can open it up for anyone who might have questions about this before I dive into the rest of the presentation.
Thank you. Sue Brandon, Sue Brandon, you want to go ahead? Yeah, you're muted though.
Susan Brown was ahead of me, but I will just ask. So Stefan, have you heard anything from Enbridge about any gas component finishing?
So we've been told that Enbridge will continue on with their program, and they are trying to pursue a top-up with the Ontario Energy Board to make it the same as what it would be with the Canada Greener Homes grant. So that's under in discussion right now, and we don't have anything, but Enbridge is working on maintaining a high level of grant availability for homeowners, and they will, under that particular program, they'll continue going. So pre-retrofit evaluations will be available with Enbridge. We just don't know the specifics about it because they were co-delivering the Canada Greener Homes grant program. So trying to decouple them to see what Enbridge will allow, because as a co-delivery system, it allowed for non-Enbridge clients to apply for the Enbridge program. So what does that mean when Canada Greener Homes grant program is no longer available? So questions that hopefully will be answered in the coming weeks. And so I hope to have an update for you as soon as I have that update.
Susan Brown had a question too.
Yeah, I just wanted to clarify when I said that, yeah, it was a $5,000 minimum grant qualification that was required for the loan. And so the amount we had in our quote, we weren't going to get the full amount that it would cost us, right? It would cost $15,000, but we were only the actual grant act was, according to Steve Greatrix, the only part of it that was eligible for the grant was $3,250.
Interesting. Yeah. Yes, and that's Susan, thanks for bringing that up, because that's certainly a side of that program that we as the energy advisor and service organization don't see too often, if at all, in the sense that the loan program, I believe CMHC has set caps for certain upgrades, and I don't believe they advertise that anywhere. So it seems to me that it's a case-by-case situation for the loan application, in the sense that once you get your energy evaluation of the house and you start to look for quotes for the upgrades that you plan on pursuing. Then you apply for the loan, and then they tell you how much you have available. So Susan, it sounds like you've kind of gone through that process and discovered that only $3,000 was eligible. So yeah, I feel like we're all a little bit in the dark. Meanwhile, I've had other people who have put on solar PV, so solar panels, and I believe it sounded like they got awarded the full $40,000 just for that. So unfortunately, I don't have any more concrete advice or information about that part of it.
Susan, you're muted. Susan, you're muted. Nope, I'm not here.
Susan, you're muted. You're muted.
Sorry. Thank you. Sorry. Yeah. No, so just thanks. So to be clear, the 5,000 is a minimum that is required a minimum grant eligibility is required to get the loan. That's the way I understood what I saw in the that's a minimum, and then the minimum, and then the 3,250 is the allowable grant for the system we chose. That's the way I understand it anyway. So
Stefan, now I muted you too. Sorry. You're muted now. It's just the feedback is really bad if we don't mute each other. Thank you.
Okay, thanks for sharing, Susan. If there are no other questions, I'll just I'll carry on with my presentation then. All right. So when we do an evaluation of a house, we always consider the house as a system, and there are many parts of this system that that contribute to separating the interior environment of a house from the exterior environments throughout the seasons. Ultimately, it's building science principles that help guide our decisions, and building science principles in its very basic form is the control of heat, air, and moisture. But of course, the thermal enclosure plays a part of it. The mechanicals that you have installed plays a part of it. The occupants in the house also plays a part of it, and obviously the environment on the exterior plays a part of it as well. So we always keep that in mind when we are making suggestions and completing the evaluation. Before one is to proceed with any sort of energy upgrade, we always recommend that you deal with bulk moisture, and you make sure that moisture stays away from the house, because water is the enemy of buildings. And so if you don't have that taken care of initially, first and foremost, then it's better to implement that first and then look into the energy upgrades that that you might want to pursue. In some cases, the upgrades play double duty because you have the ability to upgrade the bulk water management strategy as well. So keep that in mind as you move on. So at the moment, and at least for the near future, these are the general upgrades that are available under the Enbridge Her Plus program, which is that co-delivery with the Canada Greener Homes Grant program. And so these upgrades have these upper limits of grant value associated with them. When you complete an evaluation, it's all based on the EnerGuide rating system. So on the left-hand side, you get an EnerGuide label showing what your house currently is rated for, similar to the rating that you might get for an appliance, whether it's a clothes dryer or fridge or a dishwasher. This is the Homes Energuide label. So that 142 gigajoules per year that you see there is what this particular house is rated for. And gigajoules per year, to put that into perspective, it's a fuel neutral energy metric that can be converted to or from a kilowatt hour, so electricity, or cubic meters of gas, or liters of propane or oil. So it's fuel agnostic in that sense, which is nice because it's not suggesting that you need to use one fuel or the other. It could be one or the other, or a combination of several. In this particular case, you can see that there's propane that's used as well as electricity, obviously, because the lights and appliances all run on electricity regardless of the heating system and the hot water system. Below that, you see the typical new house at 113 gigajoules per year. That is this particular house, the geometry of this particular house with the code minimum insulation levels and mechanicals and window performance applied to it. And so that's what it would be. On the right hand side, we've got the renovation upgrade report, which shows the same thing, but it also shows the potential, which is the culmination of all of the upgrades that the energy advisor would have suggested in their report. So this house would go from 142 gigajoules per year all the way down to 53 gigajoules per year, which is roughly in net zero ready territory. So yeah, a few other bits of information that I like to point out at this stage. In the renovation upgrade report on page 17 or 18, depending on the rest of the report, there are these graphs, two graphs. This is the first one. It shows the amount of heat loss through these particular components of the house. The heat loss currently based on the existing house, and then the heat loss after that particular upgrade for each component. What I like about this is that it shows the potential of the upgrade that is suggested, so that you have the information, you as the homeowner have the information to say, okay, well, if I pursue, what is the lowest hanging fruit in the sense, or what is the impact of a particular upgrade, and that gives you the information to decide, well, perhaps I should pursue it, and follow the advice of the energy advisor. Now, the energy advisor only has so many, only has one chance at this particular point to provide an upgrade recommendation. It's not saying that you must do that. It's simply showing the impact of that particular upgrade. What you end up doing could be somewhere in the spectrum. So if we take Windows in this particular case as an example, it goes from 48 gigajoules per year of heat loss down to 17. Well, if you choose a window with the U value that's somewhere in between, then it's a ratio of that, and so your reduction in heat loss would be somewhere in between. So that's how I explain how to read that particular graph. The next one on this particular page shows the culmination of all the thermal enclosure upgrades and the impact on the space heating, the space cooling, the impact of the upgrade of the water heater, and the addition of ventilation if ventilation wasn't already there. Lights and appliances and other electrical always stay as a default for this, so those won't change, even though you might have much better appliances. So that space heating in this particular case, it's all those heat loss reduction strategies that's on the previous graph, plus the addition of heat pumps in this particular case. So we're looking at it as a whole house as a system approach to be comprehensive in the renovation upgrade report that we provide. and then it's up to you, your contractor, perhaps a ongoing discussion with your energy advisor, if that's a service that they provide, to figure out what might be the best approach, or at least it shows you what the end goal could be. And then you can start staging it. So this is a nice infograph from the Net Zero Renovation labeling program, where in the ideal situation, these are the stages that you would follow, but you can mix and match. What really is important is that you try to figure out what the end goal might look like. And then depending on your situation, it might be better to, instead of stage 3 being installation, maybe mechanicals might have to come sooner rather than later, because you're spending a ton of money on oil. And so it might be advantageous for you to switch over to a heat pump with maybe something else as a backup other than electric. It depends. Or you might be in a situation where renewable energy is optimal at this particular stage, so that you maximize the current grant and loan programs. And then the savings from that will help pay for the eventual upgrades to the thermal enclosure, and then eventually the mechanical systems. So you can see how there could be, this is here for guidance, but it's a choose your own adventure depending on what your circumstances are. The integrated design process is a great opportunity if a renovation is a larger scale. If you're planning a huge addition or an extensive renovation of the current house, then an integrated design process gets all the experts in the same room at the same time, figuring out what the best approach is and and then creating a plan of action, so that it would just be a matter of the contractor implementing the plan and not having to figure things out along the way. This idea is, when implemented well, can save a project money in the future, because all the decisions that need to be made along the way are actually made up front. And so very little problem solving needs to be done during the course of the construction process, which could end up being more expensive, or the project not reaching its intended performance target. When we're looking at larger...
Question.
Yes.
Janet, go ahead.
So my question is based on something I heard from an installer that I wasn't aware of that even did any work in this area. And their question was, what's your backup system going to be? And I suggested that my backup system was how I heat my home at the moment, which is wood. But I have an oil furnace, so I would be replacing my oil furnace. But her comment was that the insurance companies seem to be involved now. And the suggestion was that insurance company would not accept my my wood heating as a backup system for a heat pump. What do you know about that?
Hi, Janet. That's interesting, because as a retrofit, if it's the current situation, then I would end up defaulting to the insurance company. If they won't insure you, then either speak to another insurance company to figure out if others will allow that situation. But I certainly wouldn't go against what they say and suggest that you can go ahead with just the heat pump and the backup as the wood fireplace. Is it wood fireplace, Janet?
Yes, it is, but it's only 1,000 square meter house, and so it very adequately heats the entire area.
Yeah, and then so then my other question would be, well, what type of heat pump system are they suggesting? Most heat pumps, if it's ducted, will have, if it's all electric with heat pump, then in the air handler, there would be an electric resistance element to it. So that would be automatically the backup. If it's ductless mini splits, that would be different. If that's the case, then you might, to appease the insurance company, you might need to put in ductless electric baseboards or something to some sort of electric resistance as that secondary backup.
Okay, we'll think about it when I get that far, but I didn't want to see that it was a complete roadblock. That would make it difficult.
Yeah, I would ask more questions or see if they had other case studies that suggested, in this particular situation how that was going to go on. But perhaps we can bring this up again in the heat pump section or after the presentation.
Thank you. Thank you.
Okay, so when we're looking at it from a thermal enclosure perspective for a deep energy retrofit, there are pros and cons to going interior or exterior. Obviously, if you're already doing major interior renovations, or if you've got a heritage look to the exterior, then really the interior is the only way that you can do it. But this could be either a multi-year phased approach, or you have to move out so that work can be completed. And then you can address a lot of these issues and update the thermal enclosure at that particular time. An exterior approach is less disruptive to the occupants because you can basically live through it, and then you can just add on to the outside. Obviously, best approached if you are already redoing siding, redoing roofing, redoing the windows. If those three are in need in the near future, well, then that's a perfect opportunity to take it from the exterior and perhaps consider a chainsaw retrofit, which the chainsaw retrofit has been around for decades, and it's alluding to the fact that you take a chainsaw to the eaves of the roof, and then you wrap the roof, the entire house with an airtight membrane, an appropriate airtight membrane, and then you add insulation to the exterior of the walls, however much that might be. You add insulation to the top of the roof, and then you reintroduce the overhangs, and then add siding and roofing. It's a very effective way of achieving great air tightness and adding a significant and meaningful amount of insulation, all done from the exterior. So a homeowner could live through the process with minimal disruption from a day-to-day life. This document on the right is from a CMHC document that essentially talks about this approach. So it's not new, it's not too wacky, but not too many people are doing. In the Lanark area, Lanark Design Build Group actually took this approach on a Plenty Canada net zero renovation project that they were involved with, and they achieved great air tightness and were able to add a meaningful amount of insulation to the exterior. They added new windows, added heat pumps and a heat pump water heater, and achieved full net zero renovation status. So we're coming to the end of that particular project and hope to have a net zero reno label for them in the near future. But you can see that with these particular specs, if they can be applied in a house as a system approach, then a space heating energy savings of 75% could be achieved. When we're looking at the air tightness, so here in this graph, the bottom row is all about air leakage and ventilation. And in this particular case, a house going from about 6 air changes per hour down to 1.5 air changes per hour can save a lot of energy. So you're essentially, that difference, that 35 gigajoules per year difference, is a lot of energy waste when you look at it from that perspective, just by having unintended air leaks throughout the house. Now, just to explain a little bit, because not everyone might be familiar with air changes per hour, but when we do an air tightness test, we're depressurizing the house down to 50 pascals, negative 50. which is the equivalent of about 40 to 50 kilometer an hour wind on all sides of the building. So it's inducing air infiltration, and so all the wherever there is a leak, it'll come through. At that pressure, if the fan were to run for an hour, then the entire volume of the house would be exchanged 6 times in that 1 hour. So you can imagine that there's an energy penalty to that, but then there's also other consequences to a really leaky house, like discomfort in the wintertime, introduction of a lot of moisture into the assemblies, as well as building durability issues through condensation inside these assemblies. So lots of advantages to having a very airtight enclosure. As part of the grant program, when we do a test as part of the evaluation and we upgrade the air tightness, it automatically defaults to about a 10 or 20% target to reach in order to achieve that grant amount of $550. If the renovation process and the post retrofit test achieves an air tightness result that's 10% better than that default, or 20%, then you get a bit of a bonus. So instead of 550, you get 810 or 1,000. Now I should stress that these grant amounts are only if you have receipts that show that you've paid more than that amount to achieve that air tightness. So if you're a do-it-yourselfer and you bought a box of caulking and some tape and a few other things, and it only cost you $100, well, NRCan will only pay you $100 even if you reach 20% better than your target. So keep that in mind. Now, if you're changing windows or other contractors are doing certain things that influence the air tightness, and they have a line item in their invoice that you pay that suggests that they contributed to the air sealing strategy, well, that will count towards the amount that you paid. And if that totals more than $1,000, well, then you would be awarded the full 1,000. So just wanted to make that clear because that comes up a lot. So where are the air leaks? There are many locations. This particular image is from the Keeping the Heat In document, which is online and linked throughout the renovation upgrade report. So it's a very good document for you to go through. I definitely recommend it. Ultimately, the goal is 0 ACH. We want to make our homes as tight as possible. However, air leakage detection abilities are limited when the energy advisor arrives. It depends on the season. Sometimes, at this time of year and for the next few months, an energy advisor with an infrared camera can use that to help in identifying air leaks more easily, and certainly in areas that are perhaps hidden. When you're trying to achieve great air tightness, it does require a lot of planning and strategy. Spray foam can be part of the solution, but it is not the solution. So if, as an example, I've tested a brand new house that was 100% spray foam because it had a flat roof and they wanted to achieve the maximum R value for the walls that they were building. I tested the house mid-construction and it failed. It didn't achieve even Energy Star, and it was trying to achieve passive house levels of insulation, of air tightness. So it failed. I was able to run the fan and look for leaks. Unfortunately, I found a significant leak, which they were able to patch up and continue construction. So all that to say, it's spray foam. The presence of spray foam doesn't equal great air tightness. We always recommend to test as often as possible. Even if you're using spray foam, if your project is more extensive and spray foam is part of the solution, then before it gets covered up, we always recommend that you bring us back in to do a mid-construction test just to verify, just to be able to identify any areas of air leakage that may have been missed. Aero barrier is another option for those of you who are not aware of aero barrier. It's an aerosolized gel that gets sprayed into the house, and then the house is pressurized, and as the gel is escaping out the air leaks, it starts to self-seal, assuming that they are only small gaps. It's a very effective approach. It's an air barrier enhancement strategy. So it isn't the air barrier, but it's part of it. And obviously it will only do small holes. So if you have any large holes in your enclosure, those would need to get sealed up first. And it's honestly, it's a little bit cost prohibitive for most existing homes because of the site prep that's required. But if you're doing that interior approach and a significant renovation, it might be an appropriate solution. So that's why I put that in this slide. This is just speaking about the importance of air tightness and the amount of moisture that gets through an air leak compared to vapor diffusion. And there's always confusion in the industry about the naming of vapor barriers and air barriers. What's most important with an air barrier strategy is that it's continuous, and we are here to help you and your contractor at that point. Ventilation. So when we always say build it tight, ventilate it right. We want the house as airtight as possible. We want that 0 ACH. And when we do that, to prevent sick building syndrome, we need to ventilate it correctly. HRV and ERVs are available on the market now that prevent that sick building syndrome. So that it brings in fresh air, it exhausts stale air without the penalty of wasting that energy in heat. So it exchanges heat in the process. We recommend ERVs because of their ability to exchange moisture as well as the heat, which can help maintain comfort. Other ways of looking at these machines: lungs of the house, fresh air machine, automatic window. It does all of these functions and can even replace bathroom exhausts, which are oftentimes a source of air leakage as well. So it would help you, it would help a house minimize the air leaks. When you're looking at ERVs, high efficiency is important, but also the low power. So when these machines are running, which is 24/7 essentially, you want to make sure that you've chosen one that doesn't use a lot of electricity just to function. So those are bits of information that we as energy advisors can look into if you're looking into it. Now, as far as the grant program goes, even though air tightness is rewarded, there is no grant at the moment for ventilation systems. So this would be an additional cost for you if you are achieving great air tightness. When we look at ceilings, here is the potential. It really depends on what level of insulation is in the attic or assumed to be in cathedral ceilings where we can't see. Attic insulation can range from R15 in the existing house, and we always recommend going to R60. But really, before you add insulation, we always recommend to, especially if you have a low amount of insulation in the attic at the moment, it would be advantageous and highly recommended for a contractor to do some air sealing strategies on the floor of the attic before insulation is added, because it's preventing air leaks that will have the greater impact on the house as a system than adding insulation to reach R60. I'm not saying that you don't add insulation to R60. It's just that if you're in the process of adding that insulation, it would be worth investigating and sealing the attic floor before the insulation goes on. air leaks into attic spaces are the primary cause of issues like ice damming and a phenomenon called attic rain, where this warm, moist air enters the attic space, condenses and freezes on the underside of the sheathing, and then when there's a thaw, it thaws, it turns into liquid, and then enters the house. People might think that it's we'll get roofers in to say to have a look at the roof. The roof is fine. It's not the roof. It's the air leaks. So deal with the air leaks first, and then add the insulation. The amount of grants available are dependent on the level of insulation that is evaluated at the time of the pre-retrofit evaluation, and also how much gets added and to what proportion. So if you have multiple roofs and you're only adding or increasing the insulation of one roof, then the grant amount is prorated based on the ratio of roof area that is upgraded. And then there's the question of, well, do you go vented or unvented? If you've got an attic space, keeping the venting makes sense, but you might want to go unvented and add, in the middle case, spray foam perhaps on the underside of the roof sheathing. Now your attic is a conditioned space, and then airflow needs to be introduced into that that location so that you you minimize the moisture impact of all that warm, moist air piling up into the attic space. So adding an airflow is really important. You can see on the image on the right, that's sort of a chainsaw retrofit approach, which could be advantageous. And then now, if your attic is in conditioned space, it can be used to run ductwork if ducting wasn't available. So rather than being very intrusive on the interior space, now you can use the attic because it's considered conditioned space. Perhaps if you didn't have ducting before and you're adding in an air source heat pump, unducted, so with indoor heads, now you can use that attic space as a location to place these devices because it's now in conditioned space. So lots of pros and cons to these approaches. It depends on what that final the end game is, so to speak, and then working backwards from that to figure out what the best approach is. For the above grade walls, so here we've got the potential of going from a 2x6 wall, a standard 2x6 wall, to in this particular example, adding R20 to the exterior of it, and you can see the heat loss is cut by more than half. We chose R20 because it maximizes the grant amount, so it gives the homeowner the information about the far end of the spectrum, so to speak, or perhaps just the starting point, because our suggestion is really plus or minus, and it depends on a lot of other variables that we may not have, we either may not be aware of or may not be available to us. Similar to the attic insulation, it's prorated based on the percentage of wall area that is upgraded, because the NRCan and the programs understand that sometimes it's just not possible to upgrade 100% of the wall, either because oftentimes in Ottawa, the front of the house has a brick or stone facade, but the rest of the house has vinyl, and maybe the upgrade is only where the vinyl is, but the brick facade remains the same. Or perhaps the part of the wall that is common to the garage, it's just not possible to upgrade that, and so that doesn't get the upgrade applied to it. So instead of $5,000 to it, if R20 is applied to the above grade walls, it would be a proportion of the reduction from that. So if 50% of the wall gets R20, then it's only a $2,500 grant amount. Oops, wrong direction. So how much insulation should you put on, what type of insulation. It really depends. First and foremost, you want to take care of all those other control layers, especially the bulk water control layer. If you've dealt with air tightness, great. Then it's a matter of just how much budget you have with respect to how much insulation you can put on. And the R value is not a representation of how much it would cost. Different materials cost different amounts, and different strategies have different labor and other structural implications and costs to it. So it's difficult to know what the best strategy is from a cost benefit analysis until you've had that conversation with the contractor and come up with a few different scenarios and evaluate it from a cost perspective. What we do is we look at the building science side of things to make sure that good building science principles are followed and no unintended consequences come up. So that makes one of which is that double vapor barrier situation. We want to avoid that as much as possible, but if it's the best possible approach from a cost perspective, perhaps, then we really want to make sure that great air tightness is achieved, because like we saw in that previous slide, there's a lot of moisture that comes through an assembly through an air leak. So we can get away with double vapor barrier situations sometimes if great air tightness is achieved. So that's how we help projects along the way. Windows and doors, here are the Canada Greener Homes grant amounts. The Enbridge program has a slightly different grant amount. I think it goes up to $325. These are tied to the energy performance of the windows. And there are two metrics that are available to determine which tier of the grant program the windows fall under. There's the energy rating or the U value, and I'll discuss that in a little bit in a moment. But ultimately, as I mentioned at the start of the presentation, as long as the windows can be confirmed to be on the list in the NRCan searchable database, then we can verify the performance of it. They also must have the stickers on it, and I'll describe these stickers in a moment. But the stickers have to be on during the post-retrofit evaluation so that the energy advisor can take the appropriate photos to show that that window was updated. And then we also need to take close-up photos of the stickers themselves while they're on the window. Now, we understand that sometimes a renovation process could take a very long time before the post-retrofit evaluation is done, and you might want to take the stickers off so that they are no longer there. And if that's the case, you can do that, but you would be instructed on the photo protocol that needs to be followed, and the invoice that you provide must have the corresponding NRCan reference number for those particular windows that matches the sticker that's on the window. It also needs the U value or U factor and the SHGC or the ER, depending on which one's going. So you can do it, you can take the stickers off, but you have to follow the protocol that the energy advisor would have to go through if they were doing the final evaluation. So when you look at the sticker, here are the important numbers. You've got the U factor or U value in both imperial and metric. You've got the solar heat gain coefficient, the ER rating, and I didn't circle it, but you've also got the NRCan reference number there. The U factor is an inverse of the R value. So rather than being the higher the number, like an R value is, the lower the number is better. So a low U factor means that less heat loss is going to happen through that window. less heat loss through that window also means that the interior surface temperature of that window is going to be much higher without additional heat next to it, which means that the occupant, the occupant, will be more comfortable next to that window during the winter. So now you've got more usable space because you've got passive comfort built into this window. The solar heat gain coefficient is the amount of free heat that comes, or the free solar gain that comes through that window. A high number means more solar gain, a low number means less solar gain. In the wintertime, we want lots of solar gain because that's free heat. But in the shoulder season sometimes, and perhaps in the summertime, especially if the window is not well protected with passive cooling strategies from the exterior, we may prefer to have a lower solar heat gain. So that's something that you'd have to look at when you're evaluating the performance and the appropriateness of a particular window. The ER is a algorithm that takes into consideration the solar heat gain coefficient, as well as the U value, as well as the measured leakage of that window, and then a fudge factor of 40 to bring it up to a palatable number. It's an old metric that is considering that we're a heating dominated climate, which, you know, we do have long, cold, extreme winters, and the higher the number, presumably the better. Unfortunately, because we're in a cold winter climate that experiences hot, humid summers, a window with a high ER could be a window that has a high U factor, which is not good in the wintertime, and a high SHGC, which is not good in the summertime. So a window with a high ER may actually be a window that provides more discomfort and perhaps less energy savings than a window with a low U factor and a low SHGC. So be careful when you're looking at potential window upgrades, and we'd be happy to look at your quotes and provide a little bit of advice as far as that goes. In the foundation, now we're looking at the basement, crawl spaces, floors. This value includes all of that, everything that's modeled in the basement portion of it. And there is oftentimes potential savings there. It really depends on the particular house. Same with the above grade walls. It's a portion of it that would qualify. There is also a grant available if you put on a little bit of insulation on the floor, at least 50% of the entire basement slab. Now the addition of insulation on the floor doesn't have a huge impact on the total energy consumption of the house, but it certainly helps with comfort, and potentially, depending on the strategy, it has the potential of reducing moisture into the basement, into the house, and all the discomfort that comes with that, as well as perhaps radon. Crawl spaces also, as far as insulation goes, you know, when we upgrade the basement, we may upgrade the basement and the entire basement with, let's say, R20. If I go back to the basement amount, you get a certain amount between an additional R10 to R22, and then another amount that if you go beyond R22. We may suggest or model upgrading the entire basement with R22. It's just to show the impact of that upgrade. Sometimes the basement is completely finished. We're certainly not suggesting gutting out the basement just to add the insulation. It's more suggesting that perhaps you might be in a situation in the future where you may be excavating the exterior of the house for some bulk moisture issues or some other issues, and then now you have the opportunity to add the insulation at that time, whether a grant is available or not at that time in the long-term future. perhaps. And so you know that you have the information in this report to suggest the energy implications of adding that much insulation. So you can go ahead and do that and seizing the opportunity to have the exterior of the basement wall exposed at that particular time. If you're in a basement that is completely finished or becomes finished for some other reason, then using the strategies that we suggest on the interior side can be applied at that particular time. What we want to avoid are situations like this. So good building science principles will need to be applied in this particular situation. This is called solar-driven vapor drive, where a lot of moisture is coming into the house, where a basement is cooled, actively cooled with an AC or heat pump. And that moisture wants to go from where there's a high concentration of it, perhaps there's a flower bed just on the other side of that foundation wall, and it's being watered, and then the sun hits it, and all that moisture wants to dry to the inside. So it wants to go from more to less. Excuse me while I let my dog out. All right, I'm back. So when the moisture is trying to make its way into the house, with a standard building code minimum approved wall detail, there's oftentimes poly on the inside, and poly is this plastic membrane that is a vapor barrier. And so if it doesn't have the opportunity to dry to the inside, now that poly is the condensing plane, and so condensation happens because it's colder, and then it drips down. And if it wasn't exposed like this and it's covered with drywall, then it presents itself as a pool of water on the inside. Or in the worst case scenario, mold spores start to develop, and over time, health issues can be presented. So making sure that good building science principles are applied here, either with a smart vapor variable membrane on the top section of the wall, or foam attached to the foundation wall as a vapor throttle. So it slows down the amount of moisture that is trying to make its way through the assembly and reduces the chance of this phenomenon. Here's an example of how slab insulation can get applied. Really, the best situation to do this is if you don't have height restrictions. Sometimes it might be appropriate to put dimple mat down, which could also be sealed up and part of a radon mitigation strategy, as you can see with this image on the right. Now, space heating can get a little bit complicated, as as some of you have expressed already. There are many different ways of and many different tiers of getting grants. Ultimately, we want to double check the make and model of the system that is being presented by the HVAC contractor to make sure that it's eligible, and perhaps how much it's eligible for. It's really important because there are some systems, let's say you have an existing propane or natural gas furnace that is not very old, and you just want to exchange the AC for a heat pump. Well, now if the heat pump that is going to be presented hasn't been tested with the furnace and isn't listed with that furnace on the database, then the air source heat pump system that would qualify needs to be one that is represented as coils only, so it's independent of the furnace that is existing. So little things like that are things that you can reach out to the energy advisor to get confirmation of before the HVAC installer installs it. A small nuance that could be very costly if not double checked. Ultimately, when we're looking at the sizing of the system, it's important to understand The heating and cooling loads, which are the size of that heating or cooling system, represented typically as BTUs per hour or sometimes kilowatt hour. And our reports will usually show what the current heating and cooling loads are of the house based on the pre-retrofit evaluation. Some energy advisors will also show you the heating and cooling loads if all of the thermal enclosure upgrades were implemented. And so you can see a significant reduction of both the heating and cooling loads in this particular case. The heating loads are very dominated by that heat loss graph. So if you implement more insulation, you achieve great air tightness, you change windows to a really low U value window. This house would go from a 74,000 BTU heat load all the way down to a 28,000 BTU. The cooling load is really driven by that SHGC, or the solar heat gain coefficient. And so going from 30,000 BTUs down to 15, a little bit of the R values and U values, but really predominantly the SHGC drives that value. Really important to know, because you might be in that situation where you want to switch out your heat pump now, but in the very near future, you're going to be working towards lowering that heating and cooling load, which is important for your HVAC contractor to know, because they can size the system appropriate to the future needs, but have a system, a backup system or something available now so that it can meet the actual loads right now. And then eventually, as you work towards that more efficient thermal enclosure, the heat pump will be able to do more and more of the predominant heating load. So super important to be aware of. When we talk about heat pumps, you could also call them reverse cycle air conditioners or dual. I forget that there's another way that somebody else had described it. Essentially what it's saying is that this heat pump is like an air conditioner unit in many respects in its appearance, the fact that it cools, but the really cool thing about it, pun intended, is that it can run in reverse and provide heat in the winter. So cooling in the summer, heat in the winter, and very efficiently as well. When you look at it from an energy use or coefficient of performance, so COP, it's a very effective way of doing it. But it really depends on what your current heating load is, because if we go back to this particular heat load value, 74,000 BTUs, there are very few residential sized heat pumps, cold climate air source heat pumps, that can provide that amount of heat at the design temperature. So in Ottawa, the design temperature is -25. There are very few that can deliver 74,000 BTUs at that time. So either a commercial size system would be required, or multiple systems would be required, or perhaps you might need to consider going to a ground source heat pump instead of an air source heat pump, because it can be designed and sized appropriate to your current loads, depending on your future stages of retrofits and when they might happen. So there are many things that need to be considered when looking at heat pumps, and I'd be interested to know, I forget who it was who had the $60,000 heat pump quote, roughly. But that sounds more like a really large ground source heat pump or geothermal system. And a lot of that costs, if that is the case, is the drilling down to with the boreholes to run the pipes through there to use the ground as that heat exchange mechanism, as opposed to using the air. So there are benefits to that, but it does come at a pretty high price tag. But then it would have more of a potential of meeting the heating load than an air source heat pump. Now, there are other systems, other heat pump systems called air to water heat pumps. There's a product from Winnipeg called Arctic heat pumps, where they look like the exterior condenser looks similar to this one on the left-hand side, or even the one on the right-hand side. But instead of going air to air into a ductless mini split or into either one of these sort of configurations, an air to water heat pumps put the conditioned temperature, either heating or cooling, into buffer tanks inside the house. And then from the buffer tanks, it distributes the space conditioning in either with an air handler or radiant floor or ductless mini split, or any one of these sort of cassettes that you see on the right. The issue with air to water heat pumps right now, from a price perspective, they're somewhere in between an whole climate air to air heat pump and a ground source heat pump. But the main issue, not just the cost, but the main issue is that they're relatively new in the Canadian market, North American market, really. And so testing protocols haven't been developed to really understand how they work in our climate, even though they've worked in European and Asian climates, or similar climates than ours, for many decades. But because we don't have the protocols, we can't verify their performance, and we as energy advisors can't model them in the energy modeling software. So until Anarcan develops these modeling protocols and testing of these devices, you won't find them on any list. So that's important to understand, because these systems probably will work, because if it works in Winnipeg, it's going to work here. We just don't know how well they will perform, and we can't compare them to a ground source heat pump or an air-to-air heat pump. So those are little caveats, but perhaps worth investigating if you're interested. Fireplaces, no grants or loans with that, but this is just to say that if you are trying to make your house more airtight, that combustion safety becomes in the fore, and you have to be cognizant of that. But a good energy advisor would bring this up during the evaluation. And then hot water. So hot water, here you can see that there's a significant reduction in energy consumption for hot water. And that's largely because the typical upgrade would be to a heat pump water heater, and there is a grant of a little over $1,000, I think, with the HER Plus program. And a heat pump water heater looks like a tank, a typical tanked water heater, but it has a heat pump located in the top section of those tanks that you see on the left. It grabs the heat from the room that it's located in and very efficiently puts it into vapor form. So they tend to be about 300 to 385% efficient in using electricity to heat hot water. They pair well with drain water heat recovery systems, which is just a copper pipe that when someone's having a shower, the water that's going out will preheat the incoming cold water that's either going to the shower tap or to the hot water source. I recommend everyone consider putting in an energy monitoring system into the house, just so that you can't manage what you don't measure. And the cheapest form of energy consumption is the reduction of energy consumption. So you don't know what you don't know until you know. And so measuring it with devices like these will bring it to your phone quite literally and show you where you're using your energy and where you could potentially be switching things off. More and more technologies coming out where perhaps smart panel integration will allow for more control and load management. But that's technology that will be coming in the near future, hopefully. And then finally, solar panels. It's been discussed already. as an option for some of the members on this call. It could be something that you do immediately to reap the rewards of net metering in your location, depending on what your local distribution Hydro One has available. Perhaps you are fortunate enough to have the Tesla Powerwall available in your locations as an incentive. But usually we look at thermal enclosure first, look at the mechanicals, and then look at solar panels. But as I said at the start, your stages may be different, and you may go straight to the solar panels and then consider everything else afterwards, especially if you have a couple of EVs in the driveway. As far as the grant goes, it's $1,000 per kilowatt with a max of $5,000, and there is a resiliency incentive or bonus of $1,000 to put batteries in. Speaking of EVs, some EVs more and more, and accessories are allowing EVs to be the battery, essentially on wheels. So being able to use the battery to keep some appliances of the house running is becoming more and more available to us. So stay tuned for that. But as far as batteries go, you can consider the house as a battery as well. So if you are able to deal with the thermal enclosure and upgrade the insulation, the air tightness, triple glazed windows, adequate ERV ventilation strategy, now all of a sudden your house is essentially a battery because it loses such little heat during winter that it's storing that energy inside the house. I've heard of many colleagues in the industry who live in passive houses and clients as well. Maybe not passive houses, but somewhere in between. And they will switch off the heating system when it's -30 out, go to sleep, measuring the temperature, the interior temperature, and when they wake up, the house may have dropped maybe 1 or 2 degrees Celsius overnight when it's -30 with no additional heat. So that's what I mean by converting the house and treating it as a battery. So ultimately, just to wrap things up, this house goes from 142 gigajoules per year. With all the upgrades implemented, it goes down to 53. At 53, it's net zero ready-ish. And so solar panels can get installed on the house or the property to get it all the way to zero. And that's it. Time for questions. Or perhaps stunned silence.